Hey everyone, welcome back to AP Pre-Calc. This is lesson 2.1 to 2.3 quiz review. Let's get right into it. All right, so question number 1. The graph of the function f is shown above. Which of the following could be an expression for f? So one thing that I notice is this function falls completely below the x-axis, and that is typically an indicator where if you have an exponential function in the form a times b to the power of x, when it is below the x-axis, a is going to be negative, which is the case here. So we can eliminate a and c that have positive a values there. And then to determine what is our b. Our b should either be greater than 1 or less than 1. And so I kind of want to reflect it back. And so if I reflected it back, this is an example of a reflected exponential decay. And decay is when b is going to be less than 1. So that's what we're looking for here. So D should be our answer. If we think about graphing D kind of going to check our work, this should be, if imagine A is positive, this is an exponential decay function. And then because A is negative, you reflect it. And that would give us the graph of F that we have above that same graph there. So D should be the correct answer for number 1. Number 2, the function g is given by 2 times 3 to the power of x. Which of the following describes the end behavior of g? So what we want to do here is we kind of just want to graph this function and then see what the end behavior is. So here, this is a positive a value, so a is positive, and our b value is greater than 1. So this is the definition of an exponential growth function, which should look like this. The limit as x approaches negative infinity, as we go to the left forever, this will actually approach a y value of 0. So we can eliminate b and d. And then the limit as x approaches positive infinity of this function, this is going to go up forever, so it should be positive infinity, making C the correct answer there. All right, number 3, the exponential function is defined h of x equals a times b to the power of x, where a and b are positive constants. Which of the following is true? So taking a look here, let's see what's happening, right? We see 4 over 5 to 2 over 5, 2 over 5 to 1 over 5, right? So it's definitely getting smaller. Here we're actually multiplying by 1/2 every time. So 1/2, 10, or 1 over 10 times 1/2 would be 1 over 20. And so remember to kind of say times 1/2 instead of saying divided by 2. So times 1/2, that means our b value, our growth rate, should be equal to 1/2 here. So let's just look at the criteria first, right? Looking at these, b is 1/2, which is obviously less than 1. So we can eliminate d and we can eliminate a. And then also from this, we know that the numbers are decreasing, right? They're getting smaller because you keep cutting it in half every time. And so this is an example of exponential decay, not exponential growth, making B the correct answer there. Right, for number 4, which of the following statements is true about this exponential function? So here, A is negative, and then our B is 5, which is greater than 1. So I want to look at the general graph first. So if B is greater than 1, sketch an exponential growth function. And then because A is negative, remember to reflect it over the x-axis. So this should be our general shape there, that blue line. And so looking at that blue line, what can we say? Well, obviously it decreases, right, because it goes down. So it is going to be decreasing, so we can eliminate A and B. And then what is happening to the rate of change, right? Is it decreasing at an increasing rate or decreasing at a decreasing rate? This part right here talks about concavity. And so this part of the graph is obviously concave down, so it's going to be a decreasing rate, so D should be our correct answer there. All right, number 5, the number of students at IMG that earn a qualifying score on an AP exam can be modeled using a geometric sequence, where my first year is year 1, the number of students in year 1, so here we can write g of 1 equals 15, and the number of students in year 3, g of 3 equals 60. Which of the following gives the number of IMG students earning a qualifying score in year t, where t is a whole number? So here we kind of want to write our equation, and that's why I had you write the general form down so much for problems like this. So taking a look at this, let's first find what we usually do when we're given two terms, which is we're looking for what is our common ratio. So setting this up, write your equation g of n equals g of k times r to the power of n minus k. Here we're going to set g of n as our term that comes later, and g of k as kind of our starting term. So the first one should be g of k, and this should be g of n based off that subscript. Plug in everything except for r. So here this should be 60 equals 15 times r to the power of 3 minus 1, which is 60 equals 15 r squared. Now just solve for r, divide both sides by 15, and then take the square root of both sides. You should get r to be plus or minus 2. Plus or minus 2. However, this is a story problem, right? And in the context of story problems, you really don't look at that negative r value. So here we can just safely say r is 2. Knowing that, we can eliminate b and c, because those do not match up with our r value there. And then, what equation would be best? So remember, we are going to kind of set up that same equation again. G of n equals g of k times r to the power of n minus k. And here, we're setting up a general equation for g of n, so we're going to leave g of n and n alone. We already know our r value, right? That's going to be 2. And so what else are we plugging in? We're plugging in 1 point for g of k and k. But which one of these 2 points that we're given do we use? And the answer is you could use either. And so let's set up both equations, one with g of k being g of 1, which is 15. And then let's set up another one. Here, I'll do this one in blue, with this one being g of k equals g of 3, which is 60, and see which one matches our 2 equations. So the first one should be g of n equals, and then g of k here is 15 times 2 to the power of n minus k, which is 1. And then the next equation here, this blue one, should be g of n equals g of k, which is 60, times our r to the power of n minus 3. And so looking at these, A would be the one that matches or correlates with one of those two, because both of these are the same. However, if we wanted D to be the correct answer, this should be t minus 3, is very similar to n minus 3, not t minus 1. So that is why A is going to be our correct answer there. Number 6, let g of n be a geometric sequence with g of 1 is 27, g of 4 is 64. What's the second term in the sequence? Show all work. So this will be a short answer question on your quiz as well. I will give you that much. And it will be dealing with a geometric sequence as well. So let's set up our general equation. G of n equals g of k times r to the power of n minus k. Here, we are going to set our fourth term as g of n, and then our first term, our earlier term, as g of k. G of n is going to be 64 equals g of k, which is 27, times r, which we first want to figure out, to the power of n, which is 4, minus k, which is 1. So remember, this is n, and this is k there. Solving this, divide both sides by 27. Leave this as a fraction for now, so this will be a no calculator quiz. And then take the cube root of both sides. So the cube root of 64 is 4, and the cube root of 27 is 3. So our r value should be 4 over 3. That should be math that you should be able to do. On the quiz, I will prepare you now. There is quite a bit of just computation and calculations you'll be needing to do. So math like this should be expected at this stage in math. Right, now that we have our r value, let's plug it into our equation. So here, g of n equals, and we'll just use this as our g of k, right? 27 times 4 over 3 to the power of n minus k, which is 1. And then we want to find g of 2. So this should be 27 times 4 over 3 to the power of 2 minus 1, which is 27 times 4 over 3. Here we can cancel out a 3, and we should get g of 2 to just be 36 as our answer there. All right, on the quiz, you're going to have the similar thing. However, if you get to a point where it's like a really messy exponent, right, if you have something high, try using the same equation just with the other point as your g of k in that case there. All right, number 7, several terms of the arithmetic sequence a of n are shown above. Find a of 15, show all computations that lead to your answer. So here what we can pull from the sequence is a of 1 should be equal to 6 here, right? Our first term is going to be 6, our second term should be 4, and our third term should be 2. So a of 2 equals 4, a of 3 equals 2. And so from this, sure, we have one term, but we can also find our common difference, which should be minus 2 in this case, because it's like going down. Knowing this, just that stuff right there, we can plug this into our equation. So a of n equals a of k plus d to the power, or times n minus k, not to the power of. Here, we're going to just find a general expression for a of n first. So this should be 6 minus 2, n minus 1. And then we are looking for the 15th term. So a of 15 equals 6 minus 2, 15 minus 1. This should be 6 minus 2 times 14, 6 minus 28. And this should be negative 22, should be our answer for number 7. All right, finally, number 8. The function f is defined for all real numbers. The table gives values for f of x at selected values of x. Based on the table, which of the following function type best models function f, linear, quadratic, or exponential? So taking a look here at our y values, here our y values keep increasing, but it's looking more like a multiplication rule because it's growing really fast. It's pretty steep. We know 1.5 to 3, you multiply by 2. Obviously 3 to 6 times 2, 6 to 12, 12 to 24 times 2. And so this is going to be an example of an exponential function, and this is where you multiply by the same number. So a multiplication rule for your y values is a key that it's exponential. And then give a reason for your answer based on 3 things: the change in outputs, the change in inputs, and then values in our table. So here, this is a good answer to always put. I would start by saying over equally spaced inputs. And this shows that we looked at the change in our input values and just checked to make sure that they were equally spaced apart. So over equally spaced inputs, the outputs, and then for an exponential function, we want to say change, and then the keyword here is proportionately. Right, so that's our second part, and we're talking about the output values there. And then we want to show that we exactly looked at this table and not just memorized a random sentence. So here we want to say by a factor of 2, and that would be perfect there. So all 3 of those would get full credit for number 8. All right, so if you have any questions, please come see me in office hours, and I will see you guys later. Thanks.